Right then, so a bit more on the line stage design. I've been knocked up the silicon one tonight. A few minor differences, some different values in the bias network because silicon need a lot more voltage base to emitter to turn on, about 0.65 volts, whereas these germaniums need anywhere from 100 millivolts to sort of 250. So silicon, not only did it need different amounts of bias, the amount of gain from the transistors current wise, instead of like 37 this was giving, this thing here was giving a current gain of like 300 odd, and the same as this transistor, this was pushing like 200. So slight alterations have had to be made to compensate for that. So much higher emitter resistor, 10k here, much lower base resistor here, 4k7, it was 10k here, bigger emitter resistor here. Some of this is down to the increase in gain, some of it is to get the bias where I wanted it. It took a bit of tweaking of values to get the bias about halfway the supply voltage, which it sits around there now. It's quite close. But with these values here, the gain in the circuit was very low. It was only about 3. So tweaking it here, I thought, sod it, I'll make this one a bit higher gain. So I've got a 2200 ohm resistor in series with a 100 microfarad cap here. This filter here gives a 3 dB of about 7.5 hertz or something, I think it worked out to. 220 microfarad takes it down to like 3.5 hertz, so I'll just use a 220 microfarad here. It's only got a couple of volts across it. So that is DC bias at 10k, and then AC gain is like about 1k something, whatever that in parallel with that works out to be. And yeah, works brilliantly. So some right random, I was just going through my transistor box and I have a bag of these. This is a BF423ZL16. I know when I brought it about 5-6 years ago. I brought a box of it for a mixer I was working on, and it just had some transistors. I can't remember what I was doing now. I think it might have been on the input stage on the mixer channels or something. And a few of them had gone dodgy, and this was like the only thing I could really find. It was an odd pin out. Most TO92s will go like emitter base collector, whereas this one goes, what does it do? The side here is emitter, collector in the middle, base on the end. And the only reason I went with that, I actually have the P-type complement for a BC549. Well, the breadboard, if you look on my other video, is pretty much the same layout as what I was using for the germaniums. And I thought, I wonder if I've got a P-type transistor that has the same pin out as this P-type transistor, and it turns out this one does. This one's got the same pin out as this one, this one's got the same pin out as this one, so that was why I went with it. And that's the transistor I now have to use in this circuit, because it's not like the other circuit, it's not using any negative feedback, so biasing is a sort of, what was the word I'm looking for here? A condition, I guess. Your biasing is just a condition of the emitter resistors and the various characteristics the transistors have. So if I was to change this transistor out, I'd have to tweak some of these values. What is interesting with this circuit is if I get this germanium one, I was trying it, so say on 12.5 volt supply, it's biased at about, it was like 5.5 volts or something. If I get a lighter and just lick this transistor for a couple of seconds, you know, take it up to sort of 40 degrees, this goes right up to 8 volts. And if I then do the same on this one, it flies right up to like nearly 10 volts. Germaniums have terrible temperature drift on them. I tried it the other way around. If I get like some circuit board cleaner I've got, which is boils quite low, you can almost get ice to form, and I think you can actually if you spray it on enough. If I spray that on each transistor, just a quick squirt, it dropped right down to about 2 volts. Whereas these, heating them up way more with the lighter and cooling them down, you get about half a volt's difference either way. Silicon are just far more temperature stable than germanium are. Admittedly, these have got some slightly lower emitter resistors, which is going to sort of give them a higher temperature drift compared to the silicons, but most of what's happening there is due to germanium temperature drift. But Yeah, anyway, what to say really, I've not bothered doing a screenshot of the scope on this one. It's a bit of second harmonic, bit of third, a bit of fourth, sort of decays off. This one, I think on the last video I said this had a big peak of second and third. It has a big peak of second and fourth. So I'll just correct that whilst I'm here. This one's got more of a decay, sort of second, third, fourth, and then it goes into the noise floor of my scope. So until my mate actually gets it on his proper software when it's running, I can't really, you know, his software should actually show some interesting. It goes down to about minus 120 or 150 dB, so should actually be able to see some interesting harmonics, exactly what's going on both these circuits. But I think for now, I was looking on eBay and there's like some plastic rack ABS rack mounting closures, so I might just get one of them and line it with the conductive foil to make it RF proof, and just put two of these preamps, two of the germanium ones in it now, and make the valve one a separate build, because the valve one's going to need high voltage supply and stuff in it. One thing I can't find, well I can find them, is the bantam connectors. They look like a 3.5mm jack, but they're 4.4mm. You can find plenty of converters to go from a bantam connector to a 6.3 or a 3.5 or an XLR, but actual chassis mount bantam connectors, I found a couple of places on the internet that sell them and they're stupid money. So I'm just going to use 6.5mm, well 6.35mm 1/4" jack, essentially TRS, as the inputs and outputs, and it's just going to have to use, his desk uses 4.4mm bantam, so he's just going to have to use a 4.4 to 6.35 bantam converter, which they're not cheap themselves, but if I make a few of these with the bloody bantam connectors on, it's going to break the bank. I'm going to spend more on the bloody 4.4mm panel mount bantam connectors than I will on the rest of the bloody circuit. So yeah, it'll have this size, the 6.35mm jack. Anyway, just rambling on. So yeah, a bit more progress made. You need to get some stuff ordered and actually construct it. But as always, anyway, thanks for watching and catch you next time.